11.3 experimental and theoretical probability. I can calculate experimental probability and theoretical probability.
Nice job, Wilbur. Thank you. All right, a trial would be every single time you do an experiment, we call it a trial. So if you were to flip a coin 50 times, how many trials would I have? 50. If you consider flipping a coin an experiment and you did it 50 times, you would have 50 trials. Theoretical probability is exactly the same as probability. When we talk about probability in general, we are literally talking about theoretical probability. And theoretical probability is, everybody,
what should happen.
And you know this formula. It is favorable outcomes over possible outcomes, right?
Yes.
The new probability that we're going to talk about is experimental probability. So if somebody wants to know the experimental probability if something happens, they literally say, what is the experimental probability? They can't say what's the probability because that's theoretical. So the experimental probability is, everybody,
what did happen.
So our experimental probability has to have already been done in order for you to know it, right?
Yes.
Someone has to have already done it. So it's the number of times something happens over the number of times you do it or the number of trials. Yes, no?
Yes.
So we asked you to calculate the experimental probability of rolling a 2 on a number cube, and here's all the data from our class. You guys don't have this in our notes. Manuel's group rolled the number cube 87 times, and they got a 2 12 times, right?
Yeah.
And we turned that into a percentage, and we found that's 13.7% of the time. And so on and so forth. Sam, 6 out of 21. Izzy's group, 2 out of 21. Lavin's group, 3 out of 15, and so on and so forth. And one of my questions was, which group was the closest to the theoretical probability? And we determined that Manuel's group was closest to the theoretical probability, which was 1 out of 6, or 16.7%. Yes or no?
Yes.
Does that make sense?
Yes.
Okay. At first, we actually thought this group was the closest, didn't we? But they actually are at 20.8%, which is a little further off than Manuel's group. You with me?
Yeah.
Then what we did is we went down here and we actually, as a class, we rolled the number cube. Kelsey rolled it for us. And we figured out, or we tallied using a chart or a table, how many times we got each of the 6 numbers on the number cube. And then this number right here was our theoretical probability. We just chose the number 1, but we could have chosen any of the numbers, right? 1, 2, 3, 4, 5, 6. The probability of getting any number on a number cube is 1 out of 6, which is 17% rounded, or 1700. So 1700 is 17% rounded, right?
Yeah.
And when we did this experiment, we found that we've got a 1, 4 out of 31 times, a 2, 9 out of 31, a 3, 7 out of 31, a 4, 5 out of 31, a 5, 2 out of 31, and a 6, 4 out of 31, right?
Yeah.
And then we calculated the decimals and the percents, and we found that the number closest to the theoretical probability, again, the number closest to the theoretical probability was 4 was at 16%, right?
Yeah.
4 was at 16%, and the theoretical probability rounded is about 17%. And if we kept doing this experiment more times, let's say we got up to 500 times, do you think these percentages would get closer and closer to 17%?
Yes.
The more you do it, the more likely it is to get closer and closer to the theoretical probability. Think about flipping a coin. What's the theoretical probability of flipping a head every single time you flip a coin?
50%.
50%. So the more times you flip a coin, you're going to get closer and closer to that theoretical probability, right? You need to know the formulas for experimental and theoretical probability. Period. If you don't have them memorized, you need to get them memorized.